In this lesson, you will explore several field processors available in the real-time streaming capability of watsonx.data integration. In modern data integration environments, raw data rarely arrives in the format businesses need. Customer records may contain nested fields, inconsistent naming conventions, or sensitive information that must be masked before it can be shared. To prepare data for analytics, reporting, or operational systems, organizations must transform and structure data as it moves through a data flow. Real-time streaming within watsonx.data integration provides a powerful set of field processors that help teams reshape, clean, and enrich streaming data in real time. Let's explore several field processors available in the real-time streaming platform. We'll review how they work by building a sample data flow and using different processors to perform various transformations. To begin, create a new data flow and name it Field Processors. On the canvas, add a dev raw data source. Instead of using the default data, we'll use the sample dataset provided with this lesson. You can access the data used here in the next lesson of this course. If you'd like to try this yourself, open the lesson titled Field Processors Data for Concept, which appears after this video. We'll stop after the first batch because we only need the first 3 records. Once you've made the changes, save the configuration. When you preview the data, you'll notice that the source contains one record with a list named results. Our goal is to transform this list into individual records. Once you've verified the previewed data, exit the preview and continue. We want to transpose the items in this list into individual records. We can do this by pivoting on the results field using the field pivoter stage. To map the list into individual records, pivot on results. Click the Field to Pivot drop-down list and select /results. This converts the single record containing a list into multiple individual records. In the pivoted items path field, enter / so that each field name remains the same as in the original results list item. Once the configuration is complete, click Preview. Observe the results carefully. The source originally contained one record with a list of items. After the pivot operation, that list is transformed into 3 individual records, each representing one item from the results list. Here, you have the option to view the preview in Table View, which provides a cleaner layout. Notice the 3 dots in the field. This indicates that the field contains multiple items in a list. Close the preview and continue. Next, add the Field Flattener processor. Configure it to flatten the entire record and set the name separator to a dot. Save the changes. Run preview again. Open the preview in Table View and notice how the nested address structure is expanded. Instead of fields grouped under an address object, you now see flattened fields such as address.street, address.city, address.state, and address.zip. Close the preview and continue to the next processor. Now add the Field Renamer processor. Click the Edit icon in the Fields to Rename section and enter a regular expression to remove the address.prefix from each field name. Any regular expression brackets used, such as the one shown, will map to $1, $2, etc. So in this case, anything after the address dot will be saved as the new field name. As we didn't close preview previously, now see the option to rerun preview. Click Rerun Preview. Observe the output fields. The fields previously named address.street, address.city, and address.zip now appear simply as street, city, state, and zip. Close the preview and proceed. Add the Field Splitter processor. Configure the field to split by selecting /street from the field to split drop-down and use a space as the separator. Clear the default new split fields value. Then create two new fields named street_number and street_name, pressing Enter after each field. Save the configuration and run preview. If you encounter an error, it may be due to an extra space in the separator field. Ensure there are no extra spaces, then save the configuration and run the preview again. Observe the transformation. A value such as 2 Bryan Street is now split into two fields, street_number and street_name. Exit the preview and continue. Whenever you want to view the entire pipeline on the canvas, click the Zoom to Fit icon. Next, add the field masker processor. We want to mask the first 12 digits of the credit card number so that only the last 4 digits remain visible. Click the Edit icon in the Field Mask Configuration section to begin configuring the field mask. Select the credit card number field /cc number from the Fields to Mask drop-down list. Then apply a regular expression to identify and mask the appropriate portions of the number. The expression separates the value into groups so that the first part can be masked while the final digits remain visible. Run preview. Observe the output. The credit card number now appears partially masked, protecting sensitive information while still preserving the last 4 digits. Close the preview to proceed. Let's try another stage. This time, add the field remover processor. We'll use it to remove the phone field. In the Fields to Remove section, select /phone from the drop-down list. Save the configuration and proceed to run preview. Notice that the phone field was present earlier, but is no longer included in the records. This confirms that the field has been successfully removed. Exit the preview to continue. Next, we'll add the field order processor. The reason for using this processor is that we are moving from JSON format to CSV format. Unlike JSON, CSV requires fields to appear in a specific order. Add the field order stage to the data flow. Now specify the fields we want to keep and the order in which they should appear. To do this, select the fields from the drop-down list. Select the name field, CC number, city and date of birth. Next, configure the processor to send records to error if any of these required fields are missing. Then specify the fields that should be discarded. Select them from the drop-down list. Select the CC type field, state, street number, street name and zip. Once the configuration is complete, click Save and then run preview. Observe the output. You'll see that only the 4 selected fields remain, and they appear in the exact order we specified. Close the preview and continue to the next processor. Let's make the date of birth field a little more readable. To do this, add a field type converter processor. This processor allows us to convert field values from one data type to another. In this case, we'll convert the date of birth field into a properly formatted date field. Go to the configuration section and click the Edit icon under Conversion by Field Name. From the Field to Convert drop-down list, select the DOB field. Next, select Date from the Convert to Type drop-down list. For data format, choose Other and then enter dd/nm/yy in the Format field. Finally, click OK and then save the configuration. Now click Preview to observe the change. Notice that the original value 02/9/64 represents the date 02/9/1964. After the conversion, the value appears as a properly formatted date, making it easier to read and more useful for downstream systems. close the preview and continue building the data flow. Next, we'll try the field mapper processor. In this example, we're using it mainly for experimentation. What we want to do here is change the value of each field so that it appears in the format. Field name equals field value. Add the field mapper processor and configure it accordingly. Enter the regular expression in the mapping expression field. Now save the configuration and click Run Preview to observe the results. For example, the original value John Wick now appears as name equals John Wick. Exit preview. For more details about the field mapper or any other processor, refer to the documentation to explore additional use cases and scenarios where this processor can be applied. Next, click Zoom to Fit to see all the stages on the canvas. Add a stream selector processor to the data flow. In the configuration panel, create a new condition. Set the first condition so that any record where the name field contains the string John is routed to the first output stream. All other records will automatically be routed to the second output stream. Click Save to continue. Now add a local file system target and connect the first output stream to the local file system target. This target will store all records where the name field contains John. Go to the Output Files pull-down and change the directory template as shown on screen. Then move to the Data Format pull-down. Since the fields have already been ordered earlier in the data flow, we can now use delimited as the data format. Ensure no header line is selected for the header line field. Once done, save and continue. Duplicate the local FS stage and change the configuration details to store not John records. For the directory template, add the word not at the beginning to distinguish it from the first file. Now rename the targets to make them easier to identify. Rename the second target not John records. Rename the first target John records. Click Zoom to Fit icon to see all stages on the canvas. Next, preview the data flow. Select the John records target. You'll see that it contains two records where the name includes John. Then select the Not John records target. Its output contains the Brian Mills record, which does not include John in the name. If you look back at the source data, you can see the three original records: John Wick, John McClane, and Brian Mills. Since there are only 3 records in total, the data flow has successfully separated them into the appropriate outputs. In this video, you explored several field processors and saw how they work together to transform, organize, and route streaming data within a data flow. In the next video, we'll move from concept to practice and walk step by step through building a data flow using a field processor, helping you apply these concepts in a real implementation scenario. Let's continue to the next lesson and start building.